So we're going to start our day with Lionel. Lionel is working in a little startup. I don't know if you heard about it. It's called Rstudio. You should check out what they do. They got some cool products. So Lionel is working at Rstudio. He's working in the Tidyverse team. So he's been programming a lot of open source things from the Tidyverse, and he's been the mind behind Erlang. That's it. So he's going to talk to us about programming in the Tidyverse, so how to use the Tidyverse to do programming and how it works inside the Tidyverse. So it's your turn.
Can you hear me?
No.
Hello. So thank you, Colin, for the introduction. Today I'll be talking about programming in the Tidyverse. And the goal will be to move along that scale from the data analysis programming side to the production programming side. So on the data analysis side, we have the Tidyverse packages like dplyr, ggplot2, or Tidyr, which are designed to cater to specific data analysis tasks like data manipulation or plotting graphics. And the most important properties is that they are optimized for interactivity and iteration. We want these packages to help you to quickly iterate as you are solving data analysis problems and create scripts that are the results of this data analysis. And so quite often you will use them to create one-off scripts that are specific to a data analysis. It has to be reproducible, but it generally has one user or a few users, you and your collaborators. And then as we move along the scale, because we have the need to reuse computation sometimes, we want to if we are using the same patterns over and over, we want to take these patterns, put them inside functions so we can use them. And so on the very far right side, we have the DevTools package, which is a package to make packages. And then you have other packages like Erlang, which contains the tidy evaluation framework that we will talk about today. And then vectors that allows you to create new classes of vectors that can be used seamlessly in the rest of R. And so all of this is about structuring reusable code. And so the important properties here are flexibility and robustness, because you want these functions to be reusable by many, many users. So the Tidyverse packages are optimized for interactive analysis, but we want to be able to reuse code as well. And so I'm going to talk about how to program with Tidyverse packages. So first of all, what is the Tidyverse? It's a set of packages. I have already mentioned a few. It has a website. It has a meta package. Library Tidyverse will attach for you all the important packages of the Tidyverse. It's a set of principles. And the most important one is that it is human-centered. And what we mean by that is that R as a programming language is a bit special because most of the R users do not come from a programming background. And so the programming here is more like a tool than a goal. And we want the Tidyverse package to be as accessible as possible. It is consistent. We try to reuse the same ideas all the time, so you have a small set of ideas that you have to learn about only once and reuse everywhere. It is composable. You can use pieces from our Tidyverse packages and use them together to solve larger problems. And finally, it is inclusive. So we want a diverse Tidyverse community, and we want everyone to feel welcome to join. So what it means concretely for Tidyverse packages, the human-centered principle, is that all these packages are domain-oriented, such as graphing plots or cleaning data. They have a language-like interface, and data is the important scope in the interface of these packages. So if we take the example of dplyr, the domain is data manipulation, and it is structured around a set of verbs that read like English, so it has this language-like interface. And so, for example, if we have a data frame here, we can filter some observations from it to take specific months and day here. We can rearrange it by descending month or day order. We can select the first 3 columns, which we can also write like this, because you can have a range with the colon operator. You can select all the variables whose names ends with the time suffix. Here with mutate we create new columns. Here they are added at the end. If we use transmute, we create the columns, but we discard all the other ones, and so we get a new table with the new columns here. And finally, group by and summarize, who work well together. So summarize creates summaries of your data, and if you have grouped your data frame beforehand, you get the summaries conditionally on the levels of the groups. So one important feature of this language-like interface is that data is the important scope. You can refer to your columns directly in these expressions. So technically we call this data masking. And so here we have a filter expression, and we say that we want the observations whose height is lower than 200, and you can refer to this column directly. And the equivalent code without data masking is on the right, and there you have to be specific about where the variable comes from. So data masking is everywhere in the Tidyverse packages, in Tidyr, in dplyr, as we have seen, in ggplot2 as well. Because the AES function of ggplot2 and the vars function are data masking. You can pass the columns from your data frame directly in there. It's also in base R. So actually, the inspiration for dplyr comes from base R with these 2 functions written by Peter Dalgaard with subset and transform. And in statistical models as well, the model formula data masking. So we think it's a great feature of R. It's actually a unique feature of R. You don't find it in other languages because it helps us create these interfaces for data analysis where the focus is on the data analysis tasks and not on the subsetting of the data structures. And the downside to it is that it does make reusing code and programming a bit more complicated, and that's why we have the Tidyeval framework. So Tidyeval lives in this Rlang package, and that's how it makes it possible to use data masking in our packages. It also makes it possible for you to program flexibly and robustly with it. But it has a strange syntax. So it has this bang-bang operator. It does require new concepts, and so it's not as accessible as the other Tidyverse packages. And it's actually on the original scale. It was on the right side rather than on the left side. But people do have a need to reuse code from the scripts with Tidyverse packages, and so we have this collection of tweets here from for New Year's resolution with people wanting to learn about Tidyeval. Since it's hard, we have it can be frustrating experience as well. So on the Rstudio community website, we had even a couple of questions from users asking if Tidyeval was actually a good thing for the Tidyverse. And so one goal of this talk will be to demystify tidy evaluation. First, why do we need it? Second, do you actually need it? Because oftentimes you don't need it to reuse code with Tidyverse packages. And finally, can it be used by lay people in a simple way? So why Tidyeval? So have we seen we have data masking, and Tidyeval is all about changing the context of computation. So here we have seen how we can change the text of computation of the expression that you supply to the data frame. But we can also take it much further. So for example, we can take your computations and translate it to a SQL request. And now we, with the same interface, we can manipulate databases. But for that to happen, we need something special, because if we use a regular function like list here, and we supply expressions that try to manipulate data in it, you will get this objects not found error. And the reason for this is that these columns do not exist as objects in the workspace. And so what needs to happen is that we need to delay these computations. We need to prevent them from happening right now. And so that's how Tidyverse works. It delays computations by quoting, which is a technical term. And then we can change the context and we can resume computation. So quoted code is a bit like a blueprint for computations. And we have the function vars here from dplyr and ggplot, which is like a fundamental quoting function. All it does is take your expressions and it returns blueprints. So when you have functions that work with blueprints, that delay the computation, that makes it harder to reuse these functions with different columns, with different inputs. And there are two cases where you want to do that. It's when you want to reuse this function in a loop, and when you want to wrap another function around this, around the data masking functions. So here it's an example with a loop, and we have two column names in a character vectors, and we have the usual loop scaffolding. So we create a list of size 2, and then we loop around the strings, and inside the loop we have this pipeline, dplyr pipeline, where we want to summarize the data frame by the average of a column. And so the most obvious way to do this would be to loop over the column names and pass the column name to min here. But if we do that, we get this strange result. We get a missing value. And the reason is that what we have actually done here is to take the mean of a string, which doesn't work in R. And actually you get a missing value with a warning message. It should probably be an error, but that's what you get. And if we try to wrap this pipeline in a function, we'll get the same issue. So here we have a function that takes some data, that takes a column, and we try to summarize the data with the average of that column. And we get, if we pass a string, we get the same problem. We are trying to take the average of a string. And if we remove the quotes, now we get an object not found error. And the reason is that data masking is not a transitive property. If you look inside the function here with the data pipe summarize, it captures a blueprint. It delays the computation, but this computation involves X. It doesn't involve hair color, and that's why it doesn't work, actually. So quoted code is like a blueprint, and that means that if you want to modify the inputs, you have to modify the blueprint. And that's why we have bang bang in Tidyverse functions, because bang bang is like a surgery operator that allows you to modify the blueprint. And then you also need blueprint material, and that's why we have this function sim and enquo. So all of this amount to learn about metaprogramming, which is really far on the side of production code, which is more for package developers. So before we get there, first of all, do you need Tidyverse actually? And we'll see two techniques that allow you to reuse code from Tidyverse pipelines without using Tidyverse. So first of all, if you assume fixed column names, then there is no need for Tidyverse because nothing varies, and it's very easy to implement. So if we have this small piece of code here that computes a BMI, and we say we use it a lot in our scripts, and we want to wrap it in a function. Then it's you can just do that. You wrap it in a function. You take your data frame, and now we assume that the data frame has the columns mass and height. So it's a good idea to check that, to check the inputs, to check that the data frame does contain these columns, and to stop with an error if it doesn't. And actually, it's a good idea to check the contents of the inputs as well. To compute the BMI, we need height to be scaled in meters. And so we could check the contents of the height column. And if it appears to be not appropriately scaled, then we could return a warning to our users. So this function, you can use it like this. If you pass the wrong data frame to it, you get this error that it doesn't contain mass and height. If you pass a data frame that isn't appropriately scaled, you get this warning. And that gives your users the opportunity to rescale the variable, and now they get the BMI. So it's appropriate for specific tasks because you assume specific column names in the data frame that is passed to this function. So your callers have to ensure the existence of these columns. It's part of the data cleaning process. And then input checking is important. And what I have tried to show you here with the checking of the scaling is that the domain logic of your function, are my inputs right, is likely to have a greater payoff than worrying about having a better syntax with tidyverse. So the other technique is column-wise mapping. And this allows you to repeat operations across a set of columns by mapping. Mapping is an important notion in R. You have it in the apply family, like sapply or lapply. And the Perl package of the Tidyverse is all about mapping. So if we take map from the Perl package, what it does is it creates a loop with the function that you pass to it. It loops it automatically to apply it to each element of a vector. So on the left, we have this function ndistinct that we apply to 2 columns from a data frame. And we apply it manually to these 2 columns. And with map, we can automatically apply it to each of the columns, and we get the results as a list. And in dplyr, we have these scoped variants that use the same principle, and that allow you to map a function over a selection of columns. And there are 3 kinds of selection. You can select all columns to apply the function over those. You can select column with a predicate, and you can pass a custom selection. And all of these verbs have full dplyr features, though, so they always work within the context of a data frame, and they support groups if you pass a group table to them. They don't have any data masking, so they take objects and not blueprints, and so they are easier to program with. This is the set of scoped variants that we have. So across the columns, we have the 3 variants, all, at, and if. And then across the rows, we have the main dplyr verbs. So for example, we have mutate all, mutate at, and mutate if. So mutate all allows you to map a function over all columns. Here we pass a function that rescale its inputs. We divide it by the standard deviation. And it has the mutate semantic, so it always returns a data frame that has the same number of rows than the input. And if we mutate all columns with this function, then we get the data frame completely rescaled. We also have this syntax that comes from Perl with the formula, and that's just a shorthand to create a function on the spot, an anonymous function. And here, the dot symbol represents the function input. So the variant if takes actually 2 functions, And the first function decides which of the column will be changed. So here we are mutating all columns if they are numerics with the rescaling function. And then you can use the at variant to map a function over a custom selection. Here we are mapping the rescaling function on the first 4 columns. You can also pass character vectors of column names, which is very useful. And so this pattern subsumes the for loop that we have tried to create before. And if you use the function vars, you can pass blueprints as well. And these blueprints will be interpreted as if they are selections from the select function. So we can mutate all the columns that start with CPAL, for example. And then once you have internalized these 3 variants, they work the same way across the other verbs. So we can summarize all columns of iris if they are numeric with the min function. Or we could group by species, which is factor, and then summarize all the remaining columns. Equivalently, we can group by all the columns if they are factor. Here there are only 1 in iris, and then we summarize at the variable that start with CPAL. And so they really allow you to express what you want to do in a very flexible way. So they are incredibly useful for your day-to-day work, and you can reuse skills from per and the apply functions in base R, and you don't need any tidy-eval for looping with these scoped variants. So now on to tidy-eval, the easier parts. We are going to see 3 methods, 3 techniques. The first is pass the dots. And that's probably the easiest way to create a tidy-eval function. So say we have this pipeline where we take the Star Wars data frame, we group by the gender column, and we want to count the observation in it with summarize n. And so we could create a function around this pipeline that takes dots. It takes a data frame, it takes dots, and we pass the dots to group by. And that's all it takes to wrap that pipeline. And now we have a function that works like a Tidyverse function. And you can count by gender, and you get this table of counts. So it works because the function that receives the dots takes care of everything. It takes care of delaying the blueprints and interpreting them. And that also means that the properties of the function you pass the dots to are inherited. And so we'll briefly talk about 2 flavors of tidy evaluation. If we take these 4 functions from dplyr, mutate, group by, select, and filter, there's one of these that they all have data masking, but one of these is a bit different, which is select. Because most of the functions in the Tidyverse take actions, and some of the functions, such as select, take selections. So what I mean by action is that we have this data masking. You can manipulate your data, and then a new vector is created. And then we modify the data frame with this new vector. When we have a selection, the position of the columns is looked up in the data frame, and then we reorganize it. And so something different happens here. Excuse me. So selections have special properties. We have the function C, minus, and column, and they understand positions and names. And that's why in select you can create these ranges of variables with the colon operators, which is very useful. You can negate variables to remove them from the selection. And then you have the selection helpers that are very useful. So sometimes actions and selections appear to work the same way. So for example, here I'm selecting height, and I'm transmuting height, and I get the exact same table as a result. But if we change the input a bit, I want to select 1 and transmute 1, then I get a different result. In the first case, 1 is interpreted as a position in the data frame, and so we get the first column. And in the second case, we create a new vector 1 that is recycled to the table size, And so that's why you get this data frame that contains the vectors of 1. So what about group by? It's an interesting function because many people think that it does selections. You want to group by a selection of variables, but actually it's an action function. And so if you pass, oh, I'm sorry. If you pass a selection, you get this error that says that the variables are not registered. And the reason we made it this way is that it's actually very useful to be able to create a new vector on the spot here. And so in this example, we create a new vector, a new logical vector that represents whether the observations have a certain height. And then we have this group table, and we can summarize it. Here we take the counts of this new factor. So one tip is that when you have an action function in the player, you can always transform it to a selection function by using the @ variant that we have just seen. And so here we can group by @ and then pass ends with color to select all the columns that ends with a suffix within that vars function. So what it means for our count by function that we have just created before is that it takes actions by default because we have passed the dots to group by, which is an action function. And so we can create new vectors on the fly. But we cannot pass selection. And if you want to change that, you just take group by here, you replace it by group by @ and pass the dots to vars. And now you have the same function, but it takes selections instead. And so we can count by a carefully created selection. Passing the dots is also useful for programming with ggplot2, because we can pass the dots to AES and to vars, which both take actions. So vars is the new interface for phase setting in ggplot2. We'll always keep the formula interface, of course, but vars has new features for tidyEval, and you can pass dots to vars. And they accept names, which can be used for creating phase set titles. So here is how you can wrap a single ggplot2 component, phase set wrap. You pass the dots to vars, just as before. Here I'm also passing a labeler because by default the phase set titles do not include the variable names, but here with vars we can supply a custom name, so that's useful. And now we have a new component that can be used in a ggplot2 pipeline to create a fast setting specification. And since this takes actions, we can create new vectors on the fly. So here I'm creating a new factor from a continuous variable that has 3 levels. And you can see in the phase set titles that we get not only the phase set level for the current phase set, but also the variable name. So here we have passed a new vector, cut number of weight, cut it in 3. And so the title is not great. It's generated automatically. But it lets you pass an optional name, and then you get the right name in the title. So that's very useful. So here we have wrapped a single component, which can be composed in pipelines with the plus operator. And we'll see 2 more examples with multiple components. And the first one wraps an entire ggplot2 pipeline, and the second is about creating, merging multiple components into one. So wrapping an entire pipeline is straightforward. You just take data, a mapping specification. A mapping specification is what AES returns. And then you take dots. And we pass the dots to vars as before. And we have the whole pipeline in there in that function. So it's not a gplot component. You cannot use it with the plus operator, but you can pass data to it. You can pass AES, and you can pass additional phase setting specification because we have passed the dots to phase set wrap. If you want to merge multiple components into one, one way to do it, the most obvious way, would be to just have geom point, for example, plus phase set wrap. But actually that doesn't work because an addition pipeline must always start with ggplot. And so that's why I'm showing you this, because it's not that obvious. The right way to do it is to return a list with the component. And then you get multiple components merged into one that can be used in an addition pipeline. So passing the dots, that's an easy way of creating data masking functions. It's useful when the pipeline has only one variable part because you can only pass one set of dots to one function. It's a good idea to think about what makes your function most useful. Is it actions or is it selections? And you can see my talk at the Rstudio conference for more ideas on that topic. The second method is subsetting the data pronoun. So what if you have multiple pipeline inputs? Before we had only one part that was changing inside group by, and here we have two parts. We have inside group by and inside summarize. And we are using two columns here. So we cannot use the dots. One way to work around this is to use the data. So you can always use the data pronoun in dplyr or ggplot2 instead of supplying the unquoted variable names. And data represents the current data that you are working with, and you can subset it with dollars. And so the pipeline here is exactly the same as before. We are just using the data pronoun to refer to the variable. But then if we use the double bracket operator, that means that we can subset it with strings. And these strings, we can take them as arguments to a function that wraps the pipeline. And that means that we now have wrapped our dplyr pipeline in a function. That function takes strings. There is no data masking. And that can actually be a good thing because now it means that your function is easier to reuse by your collaborators. But if you are, of course, if you are on the, if you want to create a package, then it's maybe better to have the full Tidyverse interface. So that's where we get to interpolation. Interpolation now is getting into the meat of Tidyverse, so we will have to use bang bang, we will have to use enquo. But we can use these two things in a simple pattern of interpolation. So enquo delays the blueprints. As we have said, it prevents the computation from happening and returns the blueprints. And then we can insert that blueprint back into another by unquoted it with bang bang. And in this way, we forward blueprints from functions to functions. So that's interpolation. So if we take our functions from before, which takes a grouping variable, an average variable, and that subsets the data pronoun with it, we can replace this by bang bang, enquo, and the two variables. And that creates the interpolation pattern. We have delayed the blueprint for group var, for average var, and then we insert it back in the blueprint captured by group by and in the blueprint captured by summarize. And now we have a full Tidyverse function. You can refer to the column names unquoted. You can create new vector on the spot. You have the full data masking here in your function. And so since that's such a useful pattern that can be reused everywhere in many cases, we plan to introduce a new syntax for it, for interpolation with the double curly operator. So that comes from the group package from Jim Hester. And if you don't know about this package, it lets you create strings from other strings. And you use the curly operator to interpolate the strings from other pieces. And so it would look like this. So that's our function from before. And we can replace two concepts that are a bit difficult to learn for newcomers, quoting and unquoting, with this single concept of interpolation. So interpolation is a simple pattern for simple cases, but it can quickly get more complicated. So for example, you can have variations on what to unquote. So here we have delayed a blueprint and we haven't quoted that, but you could create custom blueprint materials such as symbols and function calls. When you have multiple blueprints, you will have to use an unquoting variance, the big bang, the triple bang. So all of this is more on the programming side, but simple interpolation should already cover many cases when you want to reuse your Tidyverse code in functions. So data masking is a unique R feature, we think. It's great for data analysis because it allows you to think about your data more directly as you're manipulating it. But it does make it harder to program with. But the takeaway from this talk is that you might not need tidyeval because there are different techniques that you can apply to reuse code. You can use fixed column names. You can map functions over columns instead of looping, so that will allow you to reuse a computation over a set of columns. And then you have the easier tidyeval techniques such as passing the dots. That we have seen for ggplot or dplyr. You can subset the data pronoun that can get you into out of any tricky situations. And then you can use the quote and unquote pattern, which will soon merge into a common interpolate operator. Thank you.
Thank you, Lionel. Are there any questions? Okay.
So you said the double curly brackets are planned, so they're not in the package yet?
Yeah, only in my head. Yes, so we have talked about it in the Tidyverse team, and so our fear is to introduce yet another syntax that will make people even more confused than they are right now. But so it's tricky, but right now we do plan to introduce this because this will allow us to to spare users from knowing about bang bang and kind of thing, and just, I mean, for me it looks easier to use, and yeah, so we do plan to implement. Probably be in the next version of Erlang.
I have a suggestion, and what I found difficult to open the R document. Whenever I don't get to the headers, I do not advanced R and programming the Tidyverse website, because the help sites within R are usually.
Yeah, that's true. That if you come across this syntax of interpolation, you have the curly curly. What are you going to Google? Get help. Actually, we cannot overload the curly in any way. So if you try to use it outside Tidyverse packages, it will basically do nothing. Curly, what it does is it opens a set of computations. It returns the last one. So it's basically an operation. And that means that if you use it outside, we'll get error that we have no control over. Yeah, we cannot improve the error. We cannot path to using. And that's the main problem of trying to improve R from the outside in our own packages. Instead of writing the language, have this to try to use bang bang outside. So bang bang, it's a double negation, right? So exclamation mark to negate a logic vector. And if you bang bang outside Tidyverse packages, it means that you negate it twice. So end result is you have converted a logical vector. So if your input cannot be converted to a logical vector such as a string, you cannot take the negation of a string, then you get an error that type is not right. But in other cases, you will get the silent behavior of double negation instead of the unquoted behavior. Yeah, that's a real problem. Trying to improve the language and how we can work with data masking, but from the outside.
So why no bang bang like just bang bang
because so that's what's our for what the data is that complicated with don't have to know what it means. Just use it. The first problem with this is that it's scary. The second thing is that now they have two independent pieces to try to use independently, and if they don't understand exactly, they can carry. So the hope with the curly is that people will be familiar with the input interpolation package, which is a very thing. And also there is only one concept to know about. You want to take an input from your function and input from have only one concept. The hope is to make it really scary to use
don't deprecate.
No. So this, so this would be this is a shortcut for bang banging. That's purely what it is. Because it surprises. We don't have a name for it. It's curly.
Actually, it's called bang bang in Bash too. You know, when
Yeah. But if you have concerns about the syntax, please send me emails. But not happened yet. You can prevent a disaster.
So when you are including this kind of syntax in your own package, or is it going with like the cran air check thing and everything? Don't you have any problem with the scope when it's checking if the variables are defined or something like that? Yeah, no?
No. So in R you can delay code, get the blueprint.
Yeah.
So that means that that's how we can extend the language from outside. We will see that you have passed 2 times the curly operator, and then we can re-enter it anyway.
Okay.
So quoting is delaying the computation, and we need to do this because if you try to compute heights smaller than 200, you have to define the object height. It has to be an object in the workspace. Yeah, so we stop it, we get the blueprint, and we resume it.
An analogy is like when you call a function, where it's not evaluated before you call within the function, in the right context.
Yeah.
But that's not specific for value though.
Right, but more on the technical side of how what. Yeah.
So
Cool. Why did that? So you mean the filters? But it depends on data. I mean, you will work with databases if you have really large data. Typically. So you would regular data frame, smallish data, and then. But like the performance depends on. Yeah, no. I'm not sure I get you.
Yeah, you're not using them in the same. So the database that you're using are, so you're not using them in the same context, so you can't really compare those. Actually, the SQL is translated to our code, so it's not. At the end, it's not that far.
So, no. But well, we try to handle as much operations as possible. I know that my colleague Garis has written Tidyverse function that allows you to compute a linear regression in a database. The way that is to solve the function that actually supports equal to position and mathematical functions. But and then you can also actually compute the linear regression within the database by the database. A lot of possible, but I don't know what exactly.
Okay, thank you. Thank you, Lionel.